So just to give a brief about this topic sets, what do we have? We saw two main properties of the sets. The first main property was that sets are unordered. First property of set. What do we mean by unordered? So set is unordered collection of items, and we create that using this like 10, 20, 30, 40. So when we say unordered, we mean that we can't do indexing and slicing. We can't do indexing and slicing. What is the purpose of indexing and slicing? To access the data from this data type, whatever it is, whether it is sets, whether it is tuple, whether it is list, whether it is string, whatever it is, indexing and slicing help us to select some part of the data. That we can't do in the case of sets because they are unordered. So they don't have any indexed locations. Second was the main property of set is that it does not allow duplicate elements. Does not allow duplicates. That was the second property. And it's a very important property because no other data type take care of these things. So we will understand about what do we mean by duplicates and how things are handled here in the case of sets. So first thing, we saw how to create a set. To create a set, you just will put some values, some data types, some elements inside this round bracket, inside this, curly brackets. These curly brackets are also called flower brackets sometimes, but this is where we put our data. Now we saw that you can have multiple values inside. You can have integers, you can have float value, you can have text, whatever you want, you can have inside. But the set will not allow duplicate. So when we were creating the set, we saw that we had elements 10, 20, 30, 40, 50, 50, 40, 30. So some elements were repeated multiple times. But when we check the set, how the data has been stored in the set after creating it, we saw that the duplicates, 2 times 50 was there, it was taken only once. So duplicates were not allowed, it filtered it out automatically. That was the set. Second thing we saw, if we try to do this set one, if we try to do set one and one, this is what we were seeing yesterday. This is a part of indexing. It's a concept of indexing. It won't allow that. If indexing is not allowed, slicing will also not be allowed. That is the thing here. So this was the basic. Now we will move forward and see if indexing is not allowed, what other ways are there to do some things. Correct? Again, if you have a very important use case of set is that, let me show you. So I have, let's say, list one. You can take tuple, you can take list. Let's say I have this data. And we have this list. And inside this list, there are some elements, and also we have the duplicates of them. What we do, sometimes we will be required to filter out the all of the duplicates of this data from this list. What will happen? If you try to find all the duplicates one by one, you will have to write few lines of code. So you will have to basically write a logic to first compare all the elements with each other. Then once you have compared the elements, you will find out the duplicates. Once you find out the duplicates, you write it down somewhere. Once you write it down somewhere, then you will write a process to remove those duplicates one by one using the processes we have seen in list, how we remove the element. So it's a lengthy process, 2-3 steps you have to take if you want to get rid of all the duplicate elements from this list. You'll be able to do after a few sessions once we talk about some if conditional statement, how do you write conditions. But for now, let me show you how easy it will be once you take the help of set. What can you do now? So we say unique val. Unique values. What I have to just do now, I'll just have to say set, and I just have to say list one. Correct? We'll just use this keyword. Correct. That is the thing I'm going to show you. So we just give this. We say take the list one and try to forcefully convert that as a set. This is the type conversion we have seen multiple times. Yesterday also we were talking about this type conversion, that we can convert a tuple into a list. We can convert a list into a tuple. Same way we can convert a list or a tuple into set also. And set we can convert into list or tuple, whatever we want. So we can interchange between the data types, all of the three. So if I do this now and I check this variable, what will you notice? That very easily, just by writing this small set of code, by just writing this much, what we have done, we have easily removed all the duplicates which were there. So essentially, we use the power of set, we use the important characteristic of set to get rid of all the duplicates. Here you can see that it does not look so promising, but when you are working on a bigger data and you have to do something like that, then you will appreciate properly. So you will get to see that also after some time. But this is one thing. Now you will say that, okay, so we have done this, but correct. Now I'm getting a set. What will we do now? So we'll say modified list. We can just simply say list of unique val. Okay, modified list, set list of unique val, and we'll check our modified list. Have you got it now? Easily? That is the thing. It's so easy. Just few steps we have done. We have first took the set and we filtered out all the duplicates which are there. Once we filtered it out, it was saved in a set, and we just did the type conversion using this keyword list, and we have got our answer. Now you can take a look that the values look like this, but once we have created a set, list from a set, these values look jumbled now. Why this is happening? This is happening because of that property I explained yesterday, that our set does not have a proper location for any element inside the set. They are always changing their locations. So that is why this is in jumbled order, but you can just do the sorting of it if you want that in properly arranged manner. This was one use case. That is how you use them one by one. Correct? So I think you must have understood this. If any confusion is there, just let me know anytime. That was one thing. After that, we have understood the set creation. Now, what will we see? How to add elements to the set. So, is there a way to add elements to the set? Yes, there is a way. So, if we can add elements to the set, what does this mean? That sets are mutable. If we can perform this operation, we can add elements to the set. It means that sets are mutable. As soon as we can modify set or any data type in any manner, by replacing it, by adding values, by deleting values, we can directly say that that data type is mutable. By now, you must be very comfortable about these terms, mutable and immutable. We have seen multiple examples of that. Let's see, how do we add the data? So in this case, we will take our, we can take, this is the set we have created, so we can use this one itself. How do we add more elements? So for that purpose, we have unique val dot add. And if I want to add 90 here, I'll just do that. And I'll be able to add this inside the set. I wanted to add 90, and I have just given the name of the data dot add and this element. Will this work for more than one element? If I want to add 101, 110, will it work? No, it will not work. So the work of add is to have only one element at a time. It can add only one element at a time into the set, not more than one. Correct? So what should we do if you want to add more elements? You have another one which is called update. So another one is called update unique val dot update. Now inside I can give 100, 100 already we have given, 110, 20. Okay, sorry. So inside this update, what you have to give is, you can give multiple elements, but you have to give it like this. You have to give as a set, as a tuple or as a list. So you might say that you want to add 110 and let's say 500 you want to add. So just you say unique val dot update, you can say 110 and 500. You can make another tuple also. I'll show 1 minute. I'll have unique val. So what has happened just now? We have given a list, we have given tuples. So once we give list and tuple, it has taken the elements from inside of this and it has taken elements from inside of this and added that inside of this set. This is what we can do. Correct? Now, you can see here in the update, we can give this also. Yeah, you can give the set of set also. If you want here, unique val dot update. There also I'll show you, but here what you should do, if you have 320 and 350 you want to add, you can do this also. This will also work. So either you can give it as a list, as a tuple, or as a set. All of them is going to work fine. So we have unique val. Got it? This is how you can do these things. Now, just take a look at it properly. If you have any confusion, let me know. First, we have used add to add one element at a time, and we can use update to add multiple elements at a time inside of the set. We got this idea? Can I set have strings? How are we getting? We are updating the set, but can we have set of set? Yeah, I'll show you that. So for making a set of set, we have to just create that to check whether it is working or not. Let's try. So I'll just say 10, 20, 30, and 40. And I'll take another set, which is 50, 60, 70, and 80. And once we say this, it is not working. Once we try to give such a thing, not working here. Okay. If I try to give a list of this, let's see whether it is working. Not working. Okay. So we can give elements like this. Let's try whether it will take strings. If I try to have Python here, working fine. So with that, it does not have any issue, but you can't take a list, you can't take a tuple, you can't take a set inside another set. Correct? This is a simple thing. So this is about the set. Why it is not taking those things? Because just after a few minutes, we'll see some operations that set can do. The union operation, intersection operation, symmetric difference, some things are there. So that is why it is not taking set of set or set of list or something like that. Got it? Now, after this, we have what we have understood, how to add elements to a set. Once we have added elements to a set, the next operation is to check how to remove elements from a set. To remove elements from the set, again, we have some options. Let's see those options. What is the first option we have? You can say unique val. This is our data from which I want to remove something. So what will I say? I'll just say dot discard. This is the first option we have, discard. And in discard, I have to give the name of the element I want to remove. Whatever num is this. 90 is the element I have to remove. So I'll just say 90. I won't give any index location, because in list we have seen that somewhere we can give the index location to remove the values, but here that does not work. You have to give the item itself. So let's say you want to remove 90 here. You just say unique value dot discard 90, and you can remove that. So what will it be? You can see unique val. 90 has been removed. Very similar to that, there is a second operation, and that is called unique val dot remove. And let's say I want to remove 110 now. So you can say unique val dot remove. We have removed 110. But you will say that they both look very similar. What is the difference between them? The difference lies here in this. Let me try to just take a look. We had this data and we said unique val.discard element. We have removed that. You have the unique val, the name of our data dot remove, the element we wanted to remove. It has been removed. What is the difference here? Let's see. The main difference between them comes out to be when we try to do unique val dot discard, and let's say I want to remove 700 from this. Is 700 present here? No. So if I try to run this operation, see what happened. And now when we try to do the same thing with remove, dot remove of 700, what is happening? We got an error. So we have discussed about this thing, that this discard is doing nothing. If the element was present there, if 700 was present inside the set, it would go find it and it will remove that smoothly. No issue. But if it is not finding that, no issues, it will just continue. No problem with that. But remove is going to stop there. It is going to give you error. It will just stop the execution at that point, saying that what element you wanted to remove is not present there. So we could not move forward. So we are stopping here. And I have discussed that if you don't want to stop like immediately, okay, suddenly you don't want to stop, so you will not be using this remove because it is stopping your application. It is stopping your program suddenly. That's a bad experience. So you can move ahead with discard. After that, the another method is, let's see the pop is working or not here. So we have unique val dot pop. Once we say unique val dot pop, what is the work of pop here? So pop is also going to remove the data, but if you don't write anything here, it is going to take any data automatically by itself, and it is going to remove that. That is the work of dot pop. But what is the difference of dot pop between discard and remove? This difference we have understood. What is the difference between discard and remove? But what does this pop do? Does anyone remember what is this pop going to do? How is this different from other ways that we delete the data? Anyone, if you remember? No one? Pop removes the record but stores in a variable. Correct, correct. So it does not store in a variable. We can store in a variable. It just gives us gives that element back to us. So what is this pop doing? When we remove 700, did it show anything? No. If you take a look, when we tried to discard 90, it did not show anything. It just smoothly removed that value. When we tried to use dot remove 110, it also did not show anything. It just simply removed that. But when we are doing dot pop, what it is showing, that it is showing the element, it is showing the value which it is removing. So what we can do now, we can save it into a variable called as removed element. Okay, so remove element is a variable that we have just now created. What will be the value stored in this removed element? This 320, because we are getting it back from that operation. That is the main advantage of pop. It gives the element back to us, whatever it is removing. Okay. Pop also removes the record same as discard. Yeah, it is also going to remove the element as discard. These are three methods using which we are removing the element from a set. Now, I hope you are clear about their functionalities. So once we have understood how to remove elements, the next operation is to see those union intersection I was talking about. What was that? So let us talk about that now. And it is a very important operation. Once we consider any big data we have created, this is going to help a lot. Now, let's say, so there are four basic operations we'll talk about. The first operation is called union. Then there is an intersection. Then there is a difference. And then there is a symmetric difference. Four basic things are there. And we'll talk about that one by one. Okay, so let us create set 1 is equal to 10, 20, 30, 40, and 50. And we'll see set 2 is equal to 40, 50, 60, 70, and these are the elements of set 1 and set 2. We'll talk about the union and intersection one by one. First thing, the first operation is set union. This is a comment I am creating, set union. So how to write set union? You just have to write set 1 dot union and set 2. And if we run this, what will you notice? This, what is set union? If you remember, the set union is something like this. In mathematics, it is basically taught. It's a concept of mathematics. The same concept is being applied here also. Let's say this is our set 1 where some elements are there. And there is set 2 which has some elements. And now what will happen? It has some elements which are 10, 20, 30, and 40 and 50 here. Why 40, 50 here? I'll tell you. 60, 70, and 80. We can just think like they have some bucket-like structure is there in which some elements are there. This is our set 1 and this is our set 2. What does set 1 has? Set 1 has element 10, 20, 30, 40, 50. Set 2 also has some elements 60, 70, 80, and 40, 50. So why I have written 40, 50 here? This is the common element between both of the set. So if the common elements are there, they can be written here because this is the intersection part. This is the common part between both of the data. What happens in union? In union, you take the elements from this also, set 1 also, and you take the elements from set 2 also. So we should have 10, 20, 30, 40, 50, 40, 50, 60, 70, 80. Total 10 elements should be there once union has been done. But you remember the property of union that 40, 50 is duplicated. Okay, duplicate. So we can't use that. Yes, I'll just show you. Wait for a few minutes. I'll show you one example. Don't worry. Now, so 10, 20, 30, 40, 50, 40, 50, 60, 70, 80. What will happen? The elements from set 1 and set 2 will be combined together to create this. There are multiple examples of these things that will come later, but for now, I'll show you something. Wait for a few minutes. This is about union. The next is intersection. What is intersection? The intersection talks about what is the common element between both of the set. What is the common element? So when we do set dot intersection set 2, we will get 40 and 50, whatever is the common element. These are intersections. Correct? These are intersections. Now, let's write that intersection also. So we have set 1 dot intersection. If you are studying something, it is obviously very important for the real world. Otherwise, why would these concepts be there? Okay, so they are very helpful. You'll get to see them one by one. I'll show you some examples just after a few minutes. We have set 1 dot intersection and set 2. Whatever is the common element in both of them selected here. That is intersection. The next is set 1 dot difference and set 2. What is the difference here? See, once we say set 1 minus set 2, actually the set difference is written like this, set 1 minus set 2. So what we are basically saying is we want to take set 1 and subtract set 2 from it, remove set 2 from it completely. So what do we have? When we take a look at it, 10, 20, 30, 40, and 50 is there. So these are the elements of set 1. Once you do set 1 dot difference set 2, only the elements of set 1 we want to take. So we should have taken all the 5 elements, but it is only showing 10, 20, 30. So what is happening now? This 40 and 50 which is there, it is a part of set 2 also. These are the elements that belong in set 2 also. So this difference does not want to have any trace of the element that is there in set 2. It wants to have everything that belongs only to set 1. So that is why we just have 10, 20, and 30. 40, 50 will not be considered when we do this. So completely set 2 we have to remove, and taking the intersection values also. Now, this is the this is the difference for us. Correct? If we do set 2 minus set 1, what will happen? In set 2 minus set 1, we will have the values 60, 70, 80. Because again, 40 and 50 is there in set 1. It's a part of that also. So we'll be left with 60, 70, and 80. This is what we get once we do this. So once we write set 2 dot difference set 1, this is the values we'll get. The last concept is called symmetric difference. So we need to write set 1 dot symmetric difference, and we'll write set 1, set 2. What is this symmetric difference? Take a look at the intersection now. What has intersection given us? 40 and 50. What is symmetric difference giving us? Everything except 40 and 50. So now you can just say that in a very basic terms, you can say symmetric difference is kind of completely opposite to intersection. What it gives us, just removing that, we get all the elements here: 10, 20, 30, 60, 70, and 80. So in the symmetric difference, all the data will be taken except the data which is common between both the sets. That is the case in symmetric difference. Correct? Now, these are the things. Whatever is common, 40 and 50 is common between both. They will not be taken, except that 10, 20, 30, 60, 70, 80, all of them will be taken here. Now, we have done some of the concepts here. To write the union, there is another symbol used also that you can take help of. So one is you can write set 1 dot union set 2 to do the union between the sets. Second is you can use this pipe symbol. It also does the same thing. For intersection also we say set 1 and set 2. This is for intersection. You can use any one. Either you can use this word dot union, or you can use this method. Same thing. There is no difference between them. And if you say set 1 minus set 2, this will be this difference we are talking about. And what is symmetric difference? To mention symmetric difference, we have to say set 1, set 2. This is the symmetric difference. So either you can mention like that, or you can mention the alternatives that I just told you now. These are some of the operations of set that we can perform. There are some other operations also, like you know that there is subset, there is disjoint set. Other things are also there. But if I tell you just as of now, you won't remember. So I'm telling you the most important ones. The rest you can, whenever you have to use, you can easily search on Google and you'll get your answer. Like I'll just give you one example. If I have, let's just say set 3. What is set 3? I have 40 and 50 here. Correct? Or I can say 40 and 10 is there in set 3. What I can check, that set 3 dot is subset of set 1. Is set 3 the subset of set 1? Subset means it's a small part of subset set 1 or not. So it will tell you true that set 3 is a subset of set 1. Subset basically means a small part of the bigger data. So that also you can check. Like this, there is disjoint set or some other things are there that you'll get to see little later. Whenever we have to use it, I'll just introduce at that time itself. Now, these were all the operations here. You can take a look. We have done union, we have done intersection, we have done difference, and we have done symmetric difference. These are the things we have seen. Now, once we have got this idea, then there is a concept called as frozen set. I'll tell you what frozen set is, but let's see one of the example of that. Where can we use something like this? The intersection, the union. It's an example to just get to tell you an idea about that. Let's say you are surfing on Facebook. Whenever you visit a profile, you must have noticed that it shows a small tab called mutual friends between two people. This shows the number of mutual friends and also the name of all mutual friends. How would you implement this functionality? If you have a set, how would you, or you don't know whether you have to use set or list or a tuple or something like that, how would you implement this functionality? Understand this question. You are using Facebook, you visit a profile, someone you are searching on Facebook, someone's name you have written in the search bar, you went to their profile and you're looking at them. You might have a connection with them. They might be in your university or they are colleague at the same company. You have some connection. So what Facebook does, it will show you a small tab where it will be written, this many mutual friends are there. And what do we have after mutual friends? It will also tell you that these are the mutual friends using their name. So once we have the number of mutual friend and name of the mutual friend, how do we use that? I've got one answer. Anyone else? First is what? You will first create my profile, your profile. How many friends are there? What is their name? You will just write. Okay, you have your profile and there is some person, some person, some person. Many people are there. Then you have your friends profile. They have also some people. So now you just created a set of both of them. What will you say? Mutual friends are simple intersection. So you can say my profile dot intersection, and we have friend profile. We do this. Okay. Now when we check our mutual friends, it will just tell you F3 and F5. Whoever is this person, the friend 3 and friend 5, they are just given a small name here. So they are the mutual friend. Like this, it's just a small example to show you the functionalities that we can use. Likewise, you can think of some union example, intersection, some difference, you can think some symmetric difference. But I'll try to give you more examples later once we get to understand more concepts about it. But for now, I think you have got the idea that these are actually useful. These are actually going to be used somewhere. Now, let us talk about the last concept in this set. The last concept is something called as frozen set. Now, what is this frozen set? If you take a look at the tuple, what we have said that let's say I have some elements here, 10, 20, 30, 40. What is this? This is a list. List is what? List is mutable. And we can have multiple things inside the list. Then I explained you about a topic which is called tuple. What was tuple? I told you and I've shown you also that tuple looks very similar to list. It can have all the data type. It can have all the flexibility of the list. But what it is, you can say, it is written like this. So once you have done this structure, what can you say? That tuples are immutable lists. Tuples are immutable lists. Can you say that? Obviously, this thing works because we have seen tuple and list look very similar. What was the functionality of tuple? That we can make a data like list, but that data can't be changed. So tuples can be said to be as immutable lists. Similarly, frozen sets are called immutable sets. We have just now seen that sets are mutable. Sets can be changed. You can add values, you can delete values. But if you want to create a set that can't be changed, you can't add elements, you can't remove elements. So you convert that set into a frozen set. How do you convert that data into frozen set? Just take a look. It's a very simple example. Rest everything is same. Once you take set 1 is frozen set, set 2 frozen set. You give some element and it will convert that as a frozen set. Correct? And now, once we try to add the element inside the set 1, once we take a look at the set 1 here, see, this is how it will show. It will not show directly as like this is a set. It will tell you now that this is a frozen set. Once this is a frozen set, you can't add elements, correct? Also, obviously, the indexing will not work because that property it will still hold. And also, this union and intersection you can perform, but again, you can't delete the elements. So if you try to do set1 dot discard and we want to remove 2 from here, it won't happen. So similarly, what we have just done, very simple thing we have done. We have taken the set and we restricted that to become immutable, or we restricted that in a way that we can't add more elements and we can't remove any elements. Other properties will hold. It will still be having the property that it won't allow duplicate elements. It will still be having unordered collection of items, but just with that one extra thing that has been added. Okay, that is a frozen set for you. So you say frozen set keyword and you just give a list, it will convert that as a frozen set. Or you can give a tuple also, it will try to convert that as a frozen set. You can give a set also and it will try to convert that as a frozen set. Now, this was the concept of set set. We have gone through whatever operations we can perform. After a few minutes at the end of the session, I'll share this file with you. You can go through it and do whatever extra things you want to do with that. Just play around with that. Now, we will move forward to the next concept, which is called dictionaries. It's also a very interesting concept, and you will be able to understand that very easily. Let's see what are dictionaries. This is the last data type we have to talk about. We talked about string, we talked about list, tuple, set. 4 we have talked about, this is the last. Now, dictionary is very unique from all the previous ones. We saw that set was having little bit uniqueness, that it was unordered and it was having unique elements only. What is a dictionary now? So in the case of dictionary, that is also created inside this curly brackets. But the thing here will be that there will be 2 things given instead of 1. So in the sets, we were making this 10, 20, 30. This was a set. But in the dictionary, we won't have only one value. We will have a pair every time. How does that pair look like? Let us see. And then we'll talk about its properties. Let's see how this thing is going to work. And this is a little bit more powerful concept. This is more powerful data type as compared to the previous one. Let's see its flexibility and its use case. So what will I do now? I will say just create a dictionary one. Okay. Or I can say profile. Just a name I'm giving. It's a variable. How to create a dictionary? It should be inside of this. But inside, if I have to give a value, it should be as a pair, not as a single element. If I try to give like my name, okay. So what will happen? It will just consider that as a set. It won't be a dictionary. How it will be considered as a dictionary? It should be like this. You have to give name, a colon, and this value. What is it now? It is a pair. And this thing complete is going to be considered as one value, not 2 values. It is one value, which is a pair. Let us see some more thing. Let me add more values. I can say that place, and I can say India. Next, I can have the roles. So now, what I can give now, I can give a value. Sorry, a key is there and a value. A key is there and a value. A key is there and a value will be there. Now, if I'm using a key, the key can be either a text, it can be a word, anything I want. So let me show you what I can have here. So roles, I want to give multiple roles. So my roles are, you can say as a data scientist. My roles are as an instructor and my roles are as a mentor also. These are my roles. So what we have given here, I've said I have, my name is this, my place is this, and my roles are this. I wanted to give multiple roles. Will it be possible in other previous data types? It won't be possible. So we can do multiple things with a dictionary. Not only this, we can have another dictionary inside this dictionary. How will we create that? So let's say I want to have roles I have written. I want to have skills. Okay, I want to have skills. So for skills, I will mention that as priority basis. On the priority basis, I want to mention. For skills, I can write that I have the skill of Python, I have the skill of machine learning. This also I can write a list of multiple skills I want to have, or a tuple of multiple skills I want to have. I can mention that. But I want to mention it as a priority. This is my first skill, this is my second skill, this is my third best skill as a priority. So I can say now I have to convert that into a dictionary. So I'll say this, and I will say first one, this, second one, this, third one, this, we have this, and so I can mention third one is deep learning. This is my third skill. So what we have just done now, after that, yeah. See, take a look at it. We have created a dictionary. It is not similar to any other data type we have seen. It's very different and it is so powerful. You can mention things very clearly and so much of the information you can give without making a mess of the information. How does it look like if I run it and if I check profile? See, very properly it will mention the things for us. What are these things here? I have told you that this data, this pair, the name, colon, my name. This is a pair because you're seeing a comma, and after that, this is a pair, then a comma. This complete thing is a pair, then comma. This complete thing is a value. So in this dictionary, there are 4 values, but 4 values are as a pair. Yeah, exactly, Rana. It is very similar to the JSON file. Very, very similar to that. Okay. So we will be sometimes converting JSON to a dictionary. And once we convert JSON to a dictionary, we can convert this dictionary to a data frame for doing data analysis. Okay. So later we'll talk about that also. It's very similar to that. Now, what do we have in dictionary? There are 2 things. The first is key, then a colon will be there, and the value for that particular key. What is important for us? These are the things important for us. These keys are just a way to find my value. So in this case, in the case of dictionary, you will be able to do indexing, but the way will be different. If you want to access this thing, you will have to access its key. It is like you want to get a data. It is inside a closed door, and this is the key for that door. If you open that key, you will be able to access that data. This is the concept here in the dictionary. Now, the key can be a number, it can be a text. The values can be a number, it can be a text, it can be a list, it can be a tuple, it can be another dictionary also. Take a look at it very properly. If you have any confusion, just let me know. What are the things I have written? You'll be able to understand. Now, how do we do indexing of that? That will be one interesting thing to see. I hope all of you must have understood. Correct? Just to. Yes, correct. So in the case of dictionary, it will also allow duplicate elements. It will also allow only unique elements. Unique means what? You can't have 2 values whose keys are same. Because key is the main important thing. I have to access this data. Key does not have any other importance for me. The only importance of key is to give me this data. If I want to access this, I will have to search for its key. So what happens here? It is very easy when we create a data as a dictionary. Why it is easy? Because you don't have to find the index of any data. You will just know its key. You can look at the key. It will be visible to you. And once I know the key, it is easy for me to access any data. So it basically is something like this. These are the keys and it is value. key value, key value, key value, key value. Let us talk about that. How do we access data from inside? Again, if you have to convert a data into dictionary, you have this dict keyword. Like set was there, like tuple, like list, those things were there. Like this, we have a dict. But I will talk about that. First, let us see something. We'll talk about how to access data from this dictionary. So what we now do, let me go here and show you the way. Dictionary access. Understand this. So I have which data profile. This is how my profile looks like. How to access it? I'll just say profile and I'll write the square bracket. Inside the square bracket, I'll not write the index number 0, 1, 2, 3, 4. I won't write that. What will I write now? I want to access these roles. So I'll just go to the key here and write roles. What is my important data? This is my important data. But if I have to reach to this data, what should I do? I should write roles, which is the key for that data. And once I mention that, this is going to access it for me. This is the simple way you access something. If I have to, let's say, get this machine learning, what should I write now in this case? Just make a guess. I have to get this machine learning. Where is machine learning? Machine learning is there inside a dictionary, which is there inside the bigger dictionary. Correct? This machine learning is a value of this small dictionary, and this small dictionary is a part of the bigger dictionary. So how will we reach to this value? How will I access this machine learning value? Any guesses? Anyone? No. Okay. So let me show it to you. I'll just take the help of double indexing. Okay, double indexing. How is this going to work? I can't write directly to, it won't work because 2 is not the part of this dictionary, the profile. Correct? I can't use 2. So what should I do first? See here, what I told you, that this machine learning is a part of this dictionary. And this dictionary is a part of the profile dictionary. Correct? So if I have to reach here, first I'll have to access this data. I'll have to access this data. Correct. That is the answer. So first what I will do now, I will access skills. Once I access skills, what will I get? I'll get access to this value, which is a dictionary in itself. Once I've got access to this, I will go inside and access this key now. I have to use double indexing. If you remember, we were talking about the tuple which was there inside a list, or a list which was inside there a tuple. So we did double indexing in that case. First we search for that list, and once we search for that list, we went inside that. It's the same thing. So first I have to write skills. Once I write skills, what I have got? I have got access to this dictionary. Once I see there is another dictionary and I have to get this machine learning, I'll simply add another one, 2. And what it will give me? It will give me that element I was searching for. It will give me the value I was looking for. This is the concept. This is something you need to understand. Okay. And now, how should we access this instructor here? Very quickly, how should we access this word instructor, this value instructor? If you can think of it. First, you see what we have to access first and what we have to access next. So we have profile, roles, and 1. Okay, let's try that. So I have profile and roles. Once I do this, what I get? I get an access to this list. Once I get access to the list, what will happen? It will have its own index number, 0, 1, 2. So I'll just have to write 1 and I'll be able to get access to this. So now you have understood how to access the data from this dictionary also. Okay, you have properly understood. Now, after you have understood the accessing the data, how do we add elements to the data, to this dictionary? How we are going to add it? We need to see that. Okay, now let's see that information. So we need to talk about adding, and then we'll talk about deleting the elements. Let's see. So I will take my profile, and inside I have to add or modify some. Both of the operations will look very similar. So in there, what should I add now? While giving priority, can we give 0? Yes, obviously you can give 0. These are just keys. These keys can be anything. It can be a number, it can be a float value also, whatever you want. But obviously it should be something that other people can also understand. That is the way to create a better data. So the next is adding and modify. So how to modify the data first? Let's understand. So now I have to say profile, and let's say I want to change the name. I want to have another person's name here. I want to modify it. So I'll just say this. Go to profile, go to name is equal to this value. Once I run this, what will happen? If you take a look at it, we have modified the data. So modifying is just a very simple operation. The way we have done this modification in a list, the same way we have to do here also. So what I did now, I first access this data, and once I access this data, I give another value to this key, and it has modified the element. Same way, if I have to add, same thing I have to do. Let's say I have profile and I want to add hobbies, okay? Or I want to add education. So in education, I want to again give something. Education is the key which is not there. So if I try to run this, it won't say key error. Education is not a key. What should we do? We can add this key and a value here. So I'll say bachelor's and also master's. These are the things I want to add. So if I run it, it will simply be added with this key and with this value. Profile, we have added name, we have added place, we have roles, we have skills, and we have education. Just now we added with this operation. Correct? This is how we can add or modify elements. If I just give an other thing here, then education will be modified. Simple thing. So we have understood this also. Take a look at it. This is how we modify and add elements. I'll show you one or two more operations, then rest we will continue to follow. Okay, let's see. The next thing. How do we delete or remove elements? For deleting and removing, we have just few options. The first option we have is this. So we can say profile. This is how it looks like. The first option we have is this. Profile and dot pop. What is this pop going to do for us? In this pop, you are going to write something. What are you going to write? Let's say I want to remove this pair. So if I want to remove this pair, I'll just give the key of that pair. I want to remove this. So you're now saying profile.pop place. And what it is going to do? It is going to delete that value from that dictionary, from the profile. So with this dot pop, you give a key here and it is going to remove something, that particular thing. If you want to delete something randomly, what will you do now? You just say profile dot pop item. Pop item. What is this pop item going to do? It will remove anything randomly. It can remove education, skill, role, name, whatever is that, it will remove anything randomly. So by default, it has removed this education. This is gone. So if we check our profile, first we popped this, then we popped the item. Both the things are gone. The next thing would be, there is a del keyword. We have seen there is a del keyword. What is this del keyword going to do? In the del, I can write this profile and a key, which I want to remove. Let's say I want to remove now the roles. So I'll just say del profile and roles. It will remove the roles now. Roles and that value and key pair, both is going to be removed. So this is the thing, correct? And the last one is, if you don't give anything, if you just say del of profile, what will happen? The complete dictionary along with its structure will be removed from the memory. There will be no trace of dictionary there. If you just want to clear the dictionary, but there should be structure of the dictionary left, which means that you want to empty the dictionary, is this. You will say profile dot clear. What it will do, it will just make the dictionary empty. Everything will be gone from now. This is the concept left. This is the thing left for you. Okay. So now this is the way we remove the elements from the dictionary.